Greetings and welcome to Astronomy at Hack. We've spent the last week and a half going through and talking about sort of our understanding of the motions of the planets in terms of astronomical history, in terms of motion and how the planets moved, and how we understood that from the times of Ptolemy in ancient Greek times to up till the modern era with Einstein's formulation of general relativity that really gave the best explanation we have to date of the motions of the planets. Now what I want to do is go back even a little bit further, back before Ptolemy, and talk a little bit about some of the very earliest history of astronomy, and over the coming weeks I'll try to do a few podcasts based on that. And what I really wanted to sort of start discussing is that astronomy is certainly the oldest of the sciences. Even in ancient times, long prehistorical times, it is very certain that people looked up at the stars and perhaps tried to understand how they moved, why they went, why they came in certain patterns. And as we talked about the planets, we know that the planets were known from ancient times. I mentioned the discovery of Uranus and the discovery of Neptune a few podcasts ago, but those were the unusual planets. Uranus and Neptune were actually discovered. The other planets, Mercury, Venus, Mars, Jupiter, and Saturn, have all been known since ancient times. So there is no discoverer of any of these planets. They have always been known since the earliest times when people looked up at the stars. And what did they see is that they noticed that the stars always rose in the east and set in the west, and they always kept the same patterns relative to each other. But they noticed that the stars, that the planets gets the name for wanderers because these planets seem to wander among the stars. Now that doesn't mean that they still didn't rise in the east and set in the west every day, just like everything else in the sky. But if you looked at the planets relative to the stars, they appeared to move through the stars. So you'd look, for example, at something like the Big Dipper, and you'd see all of those 7 stars there, and you'd come back a week later, and a month later, and a year later, and they'd still all be in exactly the same pattern. But when you watched, for example, the planet Jupiter, you would see that it would slowly move through the constellations. So sometimes it might be in the constellation of Leo, sometime it might be in the constellation of Gemini, and even the very earliest astronomers with the naked eye could very easily tell that these planets were something different. They did not have any sort of equipment to tell them what they were, but they knew that they behaved differently than the rest of the stars. They didn't do exactly the same thing. So there was quite a difference in that. Now, much of what was probably studied early on was looking at these early motions, trying to understand where the sun is rising, where the sun is setting. And people could notice that if you looked at the sun and if you watched the sun, and you can even do this today, go out and look where the sun is rising or where the sun is setting. It's your choice, take a look at it. Where does it rise or set on the horizon? Remember that place where you've observed it and come back a month later, 2 months later, 6 months later, and go from that same spot and watch where the sun rises. You will notice a big difference in where it rises. We talk about the sun rising in the east, but it doesn't rise directly in the east every day. It will, in the winter time, it will rise a little in the northern hemisphere, rise a little bit to the south of the east position, so a little bit further south of east, and will set to the south of the west. And then if you watch that over the course of the next few months, it will continually go further and further north. Eventually, on the equinox, the vernal equinox coming up in March, then it will rise exactly at the eastern point. And then as we go towards summer, it'll rise further north of east. And you can watch this. Pick out the same spot and watch how the sun rises each day. You're not going to notice a big difference from day to day, but if you come back a week or a month later, big thing is make sure you know exactly where your spot is. You need to have that exact spot. So have something that you can very easily reference. You need to be so you can compare it to positions on the horizon. But you can really see that. And that is something that many of these very ancient monuments were done. Stonehenge being a prominent one. Many of these were done to specifically track the motions of the sun and tell when the different seasons were going to be starting. You know, there were no calendars or anything as we have them directly today, where we can very easily tell when the first day of spring is going to be for this year and next year and 20 years from now and 50 years from now. We can very easily tell you that. Here was the calculations that could be done were done with some of these monuments, and that things would highlight the sun would rise in certain positions on, say, the first day of summer. And at Stonehenge, at the first day of summer, the sun will rise directly over the heel stone, one of the stones in the monument that's prominently placed out there. If you're standing at the center, the sun will appear to rise directly over the heel stone, and only on that day. So that you could be used as figuring out calendars, and was likely the ancient astronomers not just using Stonehenge, but other monuments elsewhere in Europe, Africa, Asia, even in North and South America, were used to track the positions of the stars and be able to tell, when was going to be the correct time for planting. When is it going to be time to plant? When is it the time to harvest? So that all of that was known based on the positions of the stars and the sun. And that made the astronomers of the time extremely important in order to be able to determine when this was going to occur. It was extremely important. And everything in the sky occurred very regularly, so it was very much a clockwork. You could start to make predictions. So what it made was that some of the things that weren't predictable, very easily predictable, such as eclipses, yes, we can predict them quite fine right now, but certainly ancient astronomers had a lot of difficulty in predicting eclipses because they're not on a very regular pattern. They don't occur every month. They don't do something every year. They're not an even match with exactly the orbit of the Earth, so they tend to be rather irregularly spaced, and where they occur on the Earth each time is going to be a little bit different. So that not being able to predict a total eclipse that would occur in your area would sort of shorten an astronomer's career and life at the time, not being able to predict that. Even harder to predict would have been the appearance of a comet. Comet could appear relatively suddenly, and if it was not able to be predicted in advance, which it really cannot, nowadays we certainly be able to track comets. We know when certain ones are going to come, but a new one, until it's detected, is really sort of unknown. But that would be again, it was because there was a change to the heavens. The heavens were seen as perfect and unchanging, so anything that changed in the heavens was a bad sign and was not a good thing for the astronomer who was unable to predict its occurrence. Now, in these ancient times, astronomy was not really necessarily the science that it is today. It was very closely related with the religions of the time, because the heavens were perfect. They were the divine area. That was the perfect area. Everything was perfect there. So there was a strong tie between astronomy and religion at the time, and also, as I've sort of alluded to, between astronomy and astrology. And astrology is the pseudoscience that sort of says that the positions of the stars and planets can predict what will happen here on Earth. And there was a very close tie with that in ancient times, that the astronomer and the astrologer and the priest in very earliest times would have been essentially the same person, and would have been the calendar maker, would have done all of this types of things, because you would have had to know the person who would be studying the stars and studying the heavens would be the same person who is making your calendars. It was one person who had all of these jobs, which have now spread out as we've gone towards different times. That astronomy has concentrated on the scientific aspect that we study today. So that finishes just a little discussion of the very ancient ideas of astronomy, and try to give you a little bit of an idea of that. What I'd like to do again over the coming weeks is talk a little bit about some of the ancient monuments, and then work our way through up until Renaissance times, the Greeks and the Renaissance times, that we started off talking about our history. So I'm going to try to talk a little bit about the earlier history over the coming weeks. So I'm probably talking about some of the monuments, Stonehenge, and some of the other ones coming up either tomorrow or in the next couple of days. So I hope you've enjoyed that a little bit, and I'll come back and talk about some of the actual monuments used to create these calendars next time. So until then, have a great day, everyone, and I will see you in class.